Hey Bram Chemistry Kids, it's Miss Morel here, and today we are going to look at Study Guide 11.3 Limiting Reactants. So let's go ahead and take a look at this. So it gives us this picture, it gives us a formula, and it also gives us the molar masses of these. So we have oxygen and nitrogen oxide, and then nitrogen dioxide. And so let's just take a look at this. So we've got a mole to mole ratio of 1 to 2 here. So when we look at this, if we were to have 2 moles of oxygen and then 8 moles of NO2, so that means we would have extra of this, because if we had 2 of this, we would only need 4 of this because we're going to double it. So we'll put 4 there. And so the amount of NO2 means that we're doubling this if we're doubling the others. So it would be 4 moles of NO2. And then the limiting reactant is this one. So it's our oxygen, so it's O2. And then the amount of excess, so we just take 8 minus 4, and that would be 4 moles NO. Going on to the next one, we have 1 and 2, which ironically is the same ratio we have here. So the amount of NO2 is exactly what our reaction tells us. So 2 NO2. The limiting reactant is going to be none of them, because none of them are limiting, and the amount of excess is none. So they're all used efficiently. All right, 4 and 4. So if we have 4 of this, then we would need 8 of that. So that doesn't work. So that means if we have 4 of this, we would need 2 of that. So that means this is our extra. So we'll put a 2 there. And so then if we are just doubling it, that would mean we would need 4 of those. All right, our limiting reactant then is our NO. And then the amount of excess, 2 minus 4, is 2 moles of O2. All right, we come over here, 5 and 7. So if we had 5 moles of this, that means we need to have 10 moles of this, and we don't have that. So instead we'll put this at 7, which means this is half of that, so 3.5. So we'll cross this out and write 3.5. So then how much NO2 would we have? We would have the same as the NO2. So if we have 7 of that, we'd have 7 of this. The limiting reactant then is our NO. And how much extra do we have? If we subtract these numbers, we get 1.5 moles of O2. Here we go, 1 and 4. So if we have 1 of these, at most we could only have 2 of those. So this would be 2. And so if we have 2 of those, we have 2 of those, 2 NO2. Our limiting reactant, the one that's the smallest, would be the O2. The amount in name would be, we have extra NO and we have 2 extra. All right, we'll keep going. We're doing well. All right, 0.5 and 0.2. So 0.5 would mean that we're having it. So then we would only have 1 of those, but we have less than that. We have 0.2. So it means we're dividing by 10. So if we're dividing by 10, we would have the same amount of that. So as we would have this, so we'd still have 0.2 NO2. Limiting reactant is our NO. And the amount in name of excess. So if we're dividing by 10 and we have 1, we should have 0.1. So when we subtract those, we would have 0.4 moles of O2. Now here, this is a little different. We have it in grams. So let's go ahead and take a look at this. So 32 grams. That's exactly what it tells us our molar mass is. So 32. And just for reference, this one would be 30, but there's 2 of them. So really it's 60, and this is 46. We'll write 60, and we'll write 92 there. All right, so if we have 32 grams of that, that means we need 60, about 60 of this. And so that's exactly what we have. So that's perfect. So that means we'd have exactly the correct amount of that. So we would have 92 grams of NO2. Our limiting reactant, we don't have one. And amount of extra, we don't have one. Then if we have 16 grams of oxygen, that means we're cutting this in half. That means we would cut this in half. So that means instead of 60, we would really have 30. And so this is our excess. So we would go ahead and say that we have half of this. So we'd have 46 grams of NO2. Our limiting reactant then is our oxygen. So we'll put O2. And then 50 minus 30 is, or 80, sorry. So for this one, we are going to go ahead and subtract 80 minus the 30, and that would give us 50 grams extra of the NO. Now this one is a lot harder. So it says we have to show our work. So first we need to acknowledge that our mole to mole ratio is 2 moles of NO for 1 mole, breaking my lead, of O2. Now once we have that, it tells us that we have 10 grams, I'll just slide this up, 10 grams of O2, so that's 10G, okay? It's not other poor writing. And then for every 10 grams, we have 1 mole of O2, and 1 mole of O2 contains 32 grams. That's its molar mass. And so when we multiply that out, it tells us that we have 0.325 moles of oxygen. Now, when we next do this one, the NO, if we have 20 grams of NO, we'll figure out how many moles of that we have. So 1 mole of NO weighs, so it tells us up here that 1 mole weighs 30.01. And so when we calculate that out, we come with 0.6664 moles of NO. Now, we're going to compare these ratios because we know up here we have a 2-to-1 ratio. So if we take 0.6664 and we divide by 0.325, we find that our ratio comes out to be 2.132. So since it's larger than our 2 ratio, because 2 divided by 1 equals 2, so since our ratio is 2 moles of NO for every 1 mole of oxygen, O2, this is NO. And so since our ratio is larger, that means that our NO is our excess and our O is limiting. So now that we know that our oxygen is limiting, we'll take that information and now we'll calculate our mass of our NO that we're actually using. So if we are using 0.32, oh, I think I'm supposed to have a 1 there. That's supposed to be a 1 there. Okay, 3125, and we have that of moles of oxygen. And then we have 2 moles of NO for every 1 mole of oxygen. It tells us that we then use 0.625 moles of NO. So now that we have our moles of NO, we are able to calculate the mass of our NO. So 0.625 moles of NO, and in 1 mole of NO, remember it's 30 grams. We got that from our molar mass. And so you multiply that out and I come up with 18.76 grams of NO are actually used up. Then, continuing on, we're almost finished. Then we have our mass of our NO2 that we produce. And so if we have 0.625 moles of NO2. And we have 46.01 grams of NO2 in 1 mole, so we find that in our molar mass. We come up with 28.76 grams of NO2. Now, once we know that, we're almost done. So we know that our excess of NO is 20 grams, because that's what we were given in the problem, minus the 18.76 grams, which are actually used. And so we subtract that, and we come up with 1.24 grams of NO. So when we go up here to fill it in, the amount of NO2, we calculated that at 28.76. The limiting reactant is our oxygen. And the amount in name of excess, or excess, we calculated here as 1.24 grams of the NO. All right, hopefully that helps. Take good care. Thank you guys. Wash your hands. Thanks for watching.